sorry, I didn't mean to wake you. Hey. Oh, no, don't leave, kitty. Sorry, we have a guest. Or we did. He was asleep. So, hey. Well, okay, let's see if we can keep Tukey around. I suspect we won't, but I'm gonna try. So today we are going to meet the toolkit, as you can see here. Oh, all right. Hi. Can we go to the next? Okay. Nope. Maybe. Okay. There we go. So, why R? Why do I advocate almost evangelically R? Well, because it facilitates reproducible data analysis. What is reproducible data analysis? Well, let's go through a little bit of a cutesy checklist. So, near term, it allows us to affirmatively answer the following questions. Are the tables and figures reproducible from the code that we made and the data we analyzed? Next, does the code actually do what we think it does? In addition to just what was done, is it clear why it was done? Like how the parameters were chosen, why the models selected were selected. Now, longer term, ideally, you want your code to be usable on additional data sets, not just the one you're specifically doing. And next, again, this is like kind of fantasy level. Can you extend the code to do other things beyond your specific analysis? Those are the big kind of ideals here. Okay. Come on. Sorry, my computer is struggling today because I'm asking it to both record and produce these slides and render the videos that I've already recorded and edited today. So, yeah, my computer deserves a raise. So that's why it's a little laggy. Just to give you a sense of how hard it is working. Yeah, so it's using all the CPU and like a decent chunk of the GPUs. 2 GPUs. Not all the RAM, but that explains a lot. Well, as a fiercely stubborn person, I'm going to continue. Alright, so that was a reproducibility checklist. Okay, so the toolkit. Our toolkit has 3 big pieces. 1, scriptability. So we use R for that. It allows us to tell the computer what we want it to do. Next, we have our markdown, which is actually how I made these slides that you are seeing in R. By kind of keeping all our code, like not plot, you know what I mean, and output in one place. And we do that with our Markdown and our Studio. And lastly, version control. Why is version control even a thing? Well, we'll talk about that. Git and GitHub is a really useful skill, which is why actually the bulk of the class is hosted on GitHub. Okay. So let's do a toolkit overview. GitHub is a way to, this is going to be rough. You'll have to forgive me. So GitHub is a way to provide structure and organization to all the code and files that you have. I use GitHub to organize my entire lab. So, because it's a way to keep everything in one place and have it backed up. Okay, so for each project, we have a repository, and that's where the source code lives, like the source core original copy. Now, when I want to make changes, or anyone in my lab wants to make changes, what they do is they clone that source original copy and clone it to their own desktop and their own individual R project. And once they've worked around in their R project where they're using the programming language R to write their code, they're leveraging some of the functionality of various R packages, and they're working on their version of the original. And once they kind of play around with that, get it to a place where they're happy, then what they do is they push all the changes they made back to the original. And then now if another person works on it, they will see the new updated version, as well as have a record of what changes were made. So if this is a kind of common concern in my lab, that what if they mess it up? And GitHub allows you to just press undo. It's beautiful. And people really take solace in that. Okay. So that's a little bit of a precursor for GitHub. It's great. It's fantastic, and you will love it once you get into it. Okay, so let's talk about the first solid chunk of our toolkit, R and RStudio. So what is R, and why is it always paired with RStudio? So R is a statistical programming language, while RStudio is like a nice, convenient user interface. Technically, it's called an integrated development environment, an IDE, but at its simplest, R is like the car's engine. It will go, it will do, it will follow your directions, but you have to communicate with it. And that's where RStudio comes in. It gives us more functionality and kind of a nicer dashboard so that we can get our engine, that's a mouthful, to do what we want in a way that is intuitive both to us and clearly communicates our desires to the car. And the dashboard gives us tons of extra information that you wouldn't get if you were just in a Model T. Okay, so let's take a tour of R. We'll start with the console. We'll do a couple of examples using R as a calculator. I'll talk a little about the environment. I'll load and view a data frame, so essentially a data set. Talk a little bit about accessing a variable in that data set, and then we'll wrap up with R functions. So, working with R. So the first thing we want to do is launch RStudio, which I have already done for us here. So what I'm going to do is I want to show all the panes. So I'm going to zoom out. Okay, sorry, it is taking its sweet time. So here's the default setup for R. You'll notice that there are 4 panes here, like kind of like a quadrants. The console is so. There we go. So, I mean, this is set up a little, but before we. Alright, so here's the console. It's got R code running in it. Here, obviously, I have R running, but the console is where you type in R commands and send a series of R commands. Versus, okay, so that's the left side. I'll show you what's up at the top little source chunk here in a moment, but we'll get there. So, to do, now the environment and history over here tells us what is currently usable. The environment is the stuff that R is holding in its working memory. So, versus the history, which keeps track of what you did. So here, I've mostly just installed various packages. Let's see if I can go all the way up. It keeps track of a lot of history. Okay, so the first thing I did, okay, this is a little fancy. But, okay, so here's all this code that I ran to get it so that we could have our studio running and actually making these lines. Down here in this little quadrant, we've got files, plots, packages, help, and viewer. Now I have the viewer pulled up because that is where I am displaying my slides that I wrote in R up in the source panel, which is where you can write outside code and save it. I know last time we got a little bit of a sneak peek, but oh, we're not on that slide. Let's pull up the actual slide. All right. All right. Oh, we're a little ahead. All right. Cool. Now, you can also change the default settings to show a lot of other things. Now you can click on this link here and it will take you to RStudio support, give you some kind of hints and tips about customize. Okay, my computer's really struggling right now, as you can see, because we are rendering video. We're gonna just let it take a break. Okay. So you can customize this, get it exactly how you want it. And I will show you how to do all of these things. So let's go back to view, zoom, where do we go? All right. Here. Sorry, there's a lot of stuff going on. I want to zoom the viewer because I would like to get these slides back to business. Okay, cool. So we can do a lot of cool stuff. Are we going to move ahead? Okay, so here, now I've reproduced this, so you can, please, I encourage you to follow along. You can go to the console, which is where all that wild text was, and here, what I've done, this is our code that is actually run and rendered. Every single thing in this little yellow box is code you can copy and paste and run yourself. We are going to create an object called X, and we are going to tell it to have 3 multiplied by 4 and print X. Now, the output has been printed here, and it has unsurprisingly given us the correct number, 12. Now, anytime you work with R, you can create these objects. They're technically assignments, where they have this structured in form, where you have an object name and you assign it a value. Now, how I would read this is X gets 12. So X here gets 12. That's how you read it. And everything we do in R is literally that. All the functions we do are ways to manipulate our data and our variables that we already have. Now, functions are you can think of functions as verbs. So this function is do this, and everything in parentheses is what it uses to do whatever this is. So each thing in parentheses is a piece of information that the function will manipulate. You can have multiple pieces of information. So this function do that. These are dummy functions. We'll use to this, to that, and with those as all key pieces that it will manipulate. We'll work our way up, but this is the basic idea. Now, to access pieces of a data frame. So not everything is just roaming around and floating in our console, in our computer, like X wasn't attached to anything. We can grab subsets, specific variables from data frames. Now, a data frame is like a giant Excel spreadsheet. It's the easiest way to kind of think about it, at least for now. And what we're doing with this $sign is telling it to grab a specific column here with the creative title var name for variable name. So we've grabbed var name from data frame. Now, last, packages. Packages can be installed with the install.packages function, and those are loaded with the library function. Every time you run an R session, you have to reload these libraries. And here's the basic structure. So install packages, you don't have to reinstall them. Install.packages, and then you just put as a string package underscore name. Now, obviously, in this case, but some of the packages like I've written, like Discord, NLSY links, are packages that manipulate data and functions in systematic ways. And then when you want to load that library to actually use it, you just type in library and package name. So that's just the very, very basics. I want to give you now more of an overview of where we're going. So Tidyverse. Tidyverse is a really opinionated collection of R packages. These are designed for data scientists, and all the packages share an underlying philosophy and common grammar. So they're kind of like a cohesive series of packages, of libraries together. Not everyone uses them. I was trained using base R, but in this class, because I want to show you what the data scientists do, we are going to be using Tidyverse. Although on occasion I will instinctively do things in base R, which is like the package list, library list version of R. So, okay, R Markdown. We've talked about R Studio, we've talked about R, now R Markdown. R Markdown is all about making fully reproducible reports. So each time you knit, you weave together all the like everything you've done in R, and it runs the entire sequence of things. And it uses a simple markdown syntax for text and allows you to put various chunks together. What do I mean by chunks? These are aspects of Markdown that will be run using R. And anything that's just like human narrative goes outside these chunks. So to illustrate, okay, let's show all panes, and I will show you what I mean. Okay. So, wow, this is taking forever. Okay, so this is our Markdown. Some of this stuff is a little above where you guys are at, but this is how all the slides are made with Markdown. So each of, let's just grab like some of the examples. I'm scrolling. Also, this is how we're embedding images. Okay. Here. Nope. Okay. So this little piece of code that I've highlighted, those kind of backticks, here, everything else around R is just run as Markdown, versus this little piece of R code here. Oh, let's see if this works. I think I'm going to regret this immediately. Okay. Oh, this is exciting. Okay. So I've assigned X to 12. And now we're going to get it to print 12. So I've typed in X into the console down here and asked it to tell me what 12 is. Well, tell me what is in X. And boom, it tells us 12. It spit out exactly the same thing in R. All right, so just a little extra caveat. So you'll see I kind of hid this in the notes. When you're assigning things, you want to use that arrow operator. Don't use the equal sign, because although it'll work, it's going to be confusing later. And you can use some cool keyboard shortcuts, but in general, when you're assigning things, use that arrow. All right, so here, so we can see, okay, column data frame, showed you the packages piece. Let's catch up to where we are. Okay, cool. So, in theory, we're going to take a tour of our Markdown. But clearly that's not happening. All right, let's see if we can get, okay. So, in class, I'm going to give you this demo. But the basic idea is new file. Actually, no, let's just do it now. Okay, so I got a Markdown file. Let's call it demo. And how I got here was I just made a new thing, a new Markdown, and pressed OK. Now it's going to create this. And this is what the output that it has created. So to illustrate, we're going to knit this. And we got to save it. Demo. All right, let's just leave that here. Oh. Save. Okay. So now we can render it. It doesn't let you do it until you've got something to work with. Okay. So this is knitting. So what it's doing is it's running all the lines of code and creating our output. This is basic Markdown. You can embed plots and things like that through the in-class assignments that I'm about to like cut to. You're gonna work through Markdown and slowly get comfortable with this, and it's awesome. Like, you write your R code, you can embed this. You can do this with PowerPoint, MS Word. A lot of the consulting stuff I do, I will knit, like I will write it in our Markdown and then like produce it as a Windows document. But that's the idea. Okay. So, yeah, that's the basics. We will keep plotting ahead so that I don't make this video run much longer. Okay, so your turn. I've adapted an assignment that looks at the Bechdel test. So the Bechdel test, for those of you unfamiliar, is this kind of baseline metric of how sexist a movie is. So the Bechdel test asks, really for any work of fiction, like this is a bare benchmark. You'd be surprised how many movies don't pass this. At least to have at least 2 women who talk to each other about something other than a man. And these characters have to be named. So they can't just be generic women. They have to have names. So what I'm going to ask you to do is go to the GitHub and fork the Bechdel assignment to your own GitHub page and open it up and then knit that entire file structure and follow along. So I'll see you there. Or not really. You'll follow along. Just a last little pieces of help. Oh boy, this is not ending, is it? Okay, so here's what we're gonna do. We are gonna cut the video here before I have a stroke. Now, how are we gonna do that? I'm gonna make an extra page. All right. Okay, we're wrapping up right here. Next time I'm going to talk about our markdown. So I'll see you later. Bye.